All right, welcome back. Today we are going to be going on to section 10.3, but first we have a do now. So please pause the video, attempt the do now, and then resume when you are ready to move on. All right, so if you're listening to my voice, that means you have attempted the do now and you want to check your answer to move on. So let's go over it together. So in here we have 2xy getting raised to the third power, and then x to the fourth times y squared getting raised to the fourth power. So we always work inside our parentheses. We have 2xy, and we can't simplify anything there. We have x to the fourth, y squared. We can't simplify any of that. So we are actually going to be using the power of a power property, and we're going to distribute this 3 inside to every single power. So now we have 2 to the first, x to the first, y to the first, getting raised to the third. So it's going to turn into 2 to the third, x to the third, and y to the third. Now we move on to the right-hand side. We have x to the fourth, y squared getting raised to the fourth. We're going to apply the same property. We're going to multiply these exponents. So x to the fourth times 4 is going to be x to the 16th. Likewise, y squared raised to the fourth is going to be y to the 8th. Now we can start to combine, where we have x to the third times x to the 16th. That's a total of 19 of them. So it's going to be x to the 19th. And likewise, we have y to the third, y to the 8th. I have a total of 11, so it's going to be y to the 11th. And we can do 2 cubed, whoop, that's not the color I wanted. There we go. 2 cubed is 2 times 2 times 2, which is 8. So our final answer is 8, x to the 19th, y to the 11th. Awesome job so far. Awesome. Here we go. So today we are going to be completing a guided note sheet, and you'll be able to simplify exponential expressions using what we call the quotient of powers property. Again, this is going to be section 10.3. So let's talk about what it actually means to show the quotient of powers property. So please pause the video where you are, copy down the chart, and then we will go through it together. So here is the chart to copy down. Please pause it, copy down, and we're going to fill it in together. All right, so if you're hearing my voice, that means you have copied down the chart, and we're going to be filling it together. So over on the left-hand side, over here, is what we call the quotient. It's a division problem, and the quotient is the answer to a division problem. So we all have a division problem over here. In this middle section, we're going to write out what we call expanded form or repeated multiplication form, and then we're going to write our final answer over on the right-hand side. Let me erase all this, that way it doesn't confuse you at the end. So let's look at the first problem. Let's look at this problem right here. We have 2 to the fourth over 2 squared. If I write it as repeated multiplication, well, I have 2 times 2 times 2 times 2 in the numerator, and 2 times 2 in the denominator. Well, we know that 2 cancels out there, and this cancels out here. So how many am I left with? Well, I'm left with 2 2's. We're all ballerinas. So the power is going to be written as 2 to the second power, or we say it as 2 squared. Likewise, let's go down and work in the second problem. 7 to the 6th over 7 to the 3rd. I can write it as repeated multiplication. And again, as you see, this set of 7's cancel, this set cancels, this set cancels. So how many am I left with on top? Yeah, I'm left with 3. So I have 7 to the 3rd power. Let's look at the third problem now. We have -4th raised to the 5th and -4th raised to the 4th. If I write it as repeated multiplication, you can see again, this set cancels, this set cancels, this set cancels, this set cancels. So how many am I left with? Well, just 1. So I have just -4. And now our last problem, we have 11 to the 4th over 11. which we just say is 11 to the first, or just 11. So we have 4 on top and 1 on the bottom. Well, this set cancels. And now we're left with how many? Yeah, 3. So we have 11 to the 3rd power. We also call it cubed. And we're able to use all of this to generate a rule. Well, if we have a to the m power in the numerator over a to the n power in the denominator, well, what did we do every single time? Well, we canceled them out, then whatever we were left with, that was our answer. Well, we can also just subtract them. If we go back and apply this, let's just do it to the 3rd and 4th problem we did. -4th raised to the 5th and -4th raised to the 4th. Well, we ended up with 1. It's a really bad 1. We ended up with one of them. Well, if we go back to the original, we did 5 minus 4, and that gives us 1. If we look at 11 to the 4th over 11, this is like 11 to the 1st. Well, what's 4 minus 1? 3. So the rule applies, and we've shown that the rule applies, so we can move forward and trust that this is the rule about the quotient of powers property. But let's go through some examples. So I have 4 examples so far. There's going to be 2 more down here, but we'll get there later. We have 4 examples so far right here. So please pause the video, copy them down, and then we are going to be going through them together. So if you're listening to my voice, that means you have copied down the problems, and we are going to be doing these 4 together, and then we'll get on with the other 2 at the end. So for number 1, we have 2 to the 6th over 2 to the 4th. Well, using the property, it's going to be 2 to the 6 minus 4, so I get 2 squared. For number 2, I have the quantity -7 raised to the 6th divided by the quantity -7 raised to the 3rd. Well, again, using this property is going to be the quantity of -7 to the 6 minus 3 power. So I get the quantity of -7 raised to the 3rd. If we go down to number 3, this is actually a 2-step problem here. So for number 3, we have 3 squared times 3 to the 4th divided by 3 to the 3rd. So this is, again, a 2-step process. We're going to simplify the numerator first. We have the same base of 3, and we're multiplying them. So when we multiply exponents, we add the exponents together. So it's going to be 3 to the 6th over 3 squared. And now we have the quotient property to apply. So our answer is going to be 3 to the 6 minus 3, which is simply 3 to the 3rd power. And 4, again, is another 2-step process, but we can do it. We have a to the 10th over a to the 6th times a to the 7th over a to the 4th. Well, when we multiply fractions, we know we multiply straight across. So we can do a to the 10th times a to the 7th. Same base, getting multiplied, which means we add the exponents. So we get a to the 17th. That's going to be divided by a to the, oh, not the color I chose. Come on now. There we go. Divided by a to the 6th times a to the 4th. Same base, that means we add the exponents. It's going to be over a to the 10th. Which means our final answer is going to be a to the 7th, because 17 minus 10 gives you 7. So these are 4 examples where we have the bigger exponent in the numerator. For number 1, 6 is bigger than 4. Number 2, 6 is bigger than 3. Number 3, 6 is bigger than 3. Number 4, 17 is bigger than 10. But what happens if we have these 2 examples where we have bigger exponents in the denominator? Let's show what happens with that. So if we look at number 5, we have x to the 3rd divided by x to the 7th. Let me rewrite that for you in what we call expanded form, or the repeated form. X times X times X over, a lot of them, 1, 2, 3, 4, 5, 6, 7. Okay, so let's talk about what happens here. Well, can I cancel out anything? Yeah, these x's cancel, these x's cancel, and these x's cancel. So, do I have any more x's in the numerator? No, I don't. But what number is going to be in the numerator? What's anything divided by itself? 1. And that's going to be over, well, how many x's do I have in the bottom? Well, let's count it out. I have 4 x's in the denominator. It's going to be 1 over x to the 4th. Now, if we go back to our original problem, we had a 3 in the numerator and a 7 in the denominator. Well, what's a way we can get 4 from 3 and 7? Now, our rule applied, we would do 3 minus 7, but that doesn't give us 4. That would give us negative 4. So what we can alter very slightly from our rule is we look for the numerator or denominator, whichever has the bigger exponent, that's where your exponents are going to end up. So if you look at it, 7 is bigger than 3. And a way to get 4 was 7 minus 3. And that got us to 4. So notice how 7 was in the denominator, and look where we ended up. Our variable is in the denominator, and the exponent is in the denominator. Let's see if we can apply that for number 6. So for number 6, we have y squared times y to the 4th, all divided by y to the 9th. Well, we can simplify the top. We get y to the 6th, and that's getting divided by y to the 9th. Now, normally, we would do 6 minus 9, because it's a to the m over a to the n, but that's not going to give us a positive exponent. We have 6 y's in the numerator and 9 y's in the denominator. Does the numerator or the denominator have more y's? Well, the denominator. So it's going to end up being 1 over y to the 9 minus 6, and we get 1 over y cubed. Awesome job. Awesome job. So next slide is going to be your assignment. So let's show you what you have to do. You have these 4 problems to do. Okay, 1, 2, 3, and 4. So please complete these problems. On the next slide is going to be the answer. So if you pause the video, attempt them, and then check the slide next, that is going to be the answers to check your work. Now, I'm also going to be including a challenge problem in case you find this to be a little more straightforward and you feel that you're getting a good grasp on it. Okay, there's going to be a challenge problem included within the next 2 slides. So please, this is your assignment, these 4 problems, and you're going to look out for a Google form to answer. And then the next slide is going to be the assignment answers. Following that is going to be a challenge problem, and following that will be the answer to the challenge problem. So try it out, okay? I'm proud of you. You're doing so well with this. Here's the assignment. Here are the assignment answers. If you want to attempt the challenge problem, this is the challenge problem. Simplify the following expression. 12xy over 7x to the 4th times 7x to the 5th y squared over 4y. If you want to attempt the challenge problem, please pause the video, attempt it, and then resume when you want to check your answer, because I'm about to end this video with the answer to the challenge problem. Here you go. Here is the answer to the challenge problem and the work behind it. We get 3x squared y squared. Again, I'm so proud of you all. You're doing so well. If you have any questions, send out an email and we'll be happy to answer as quickly as we can. Thank you so much. Have a great day, folks.